to video 5.1, Introduction to Sampling Distributions. So I want to remind us before we were talking about a population and taking samples from it. Okay, so we had our population cloud. And then we took there's a couple different ways that we could sample. We could take a voluntary response. Now the problem with a voluntary response is it doesn't represent the population. So it doesn't look like the population. So instead of cloud, I'm going to put a rectangle around it. It's a sample from the population, but it doesn't look like the population. We also tried a convenience sample. It's a sample, but it doesn't look like the population either. Okay. So these are poor sampling methods. We want to have a good sampling method. So the best one that we can do is an SRS. And the SRS, the reason it's so good is it's going to look like the population. It represents our population. So it represents whole population. And the reason that's important is because we're trying to estimate a population value. So if you want to estimate a population value, you need to have a sample that resembles the population. Okay, so when we are representing our samples and when we're representing our parameters, we want to use the correct notation. It's very important. So if we were talking about the proportion of a sample, we would use p hat. The p hat helps us estimate P, which is our population proportion. So our sample p hat helps us estimate P, which is our population proportion. If we were talking about means, our sample is going to give us X bar, and that is going to help us estimate mu, which is the population mean. Okay. We could have S, which is our sample standard deviation, which helps us estimate sigma, which is our population standard deviation. Okay. Then we can take it a little bit further if we want to find the difference between two samples. So we can have a difference in proportion. So we would take the two sample proportions will help us estimate the difference in population proportions. And then we did the same thing with means, that we would take our two samples and find the difference of means, and that will help us estimate the difference in population mean. Okay, so it's really important that you use the proper notation, and that's going to be our first AP tip today. Your notation matters. You will lose credit for using the incorrect notation when showing your work. So if you're talking about a sample mean, you have to be sure you use X bar. If you're talking about a population mean, you have to use mu. If you use them incorrectly, you're going to lose points. And so when we're trying to maximize our pre-response points, we don't want to lose it on something like notation. All right, so let's refer back to where we did a sampling with Beyonce's Crazy in Love. Initially, I had you choose just by sight 5 words, and we found the average word length. Then we did an SRS where all the words were numbered, and you used your random number generator to generate a sample of 5. And then you found the average word length and posted it on our class dot plot. And so here's our dot plot from that day. So we collected our data and we put it up on our dot plot. And then I would ask you, what does this dot represent? So that dot is one sample of 5 words with an average word length of 4 letters. Okay, then I would ask you, what does that dot represent? So that dot is a different sample of 5, so it's one sample of 5 words with an average of, this is 3.2, 3.4. So each dot is a sample, represents a sample of 5 words and the average calculated from that sample. So remember, you have to be able to identify what each dot means. So this dot plot represents many samples of 5 words and the average calculated for each. All right, so what we have here is many samples. So what this is the sampling distribution. And we reported the mean from the sample, so we're going to say of X bar. So that dot plot is a sampling distribution of X bar. So that's going to bring us to our second AP tip for today. Be very careful with your words. You do not want to say sample distribution when you actually mean sampling distribution. A sample distribution is one sample. Sampling distribution represents many samples. And so that's an easy way to lose points by using the incorrect terminology. It seems subtle, but the difference is very important in our AP Stats world. So we want to make sure we use the correct terminology. Now, we wonder, what makes a good statistic? So a good statistic will really, what it comes down to is we're trying to estimate a population value of some kind. So how close is that statistic to the population value? So a good statistic has 2 things going for it to help it be closer to the population value we're trying to estimate. One is the center of the sampling distribution. Is around the true mean. Okay, so for our Crazy in Love example, the center of the sampling distribution is around the true mean. I actually know the true mean, which we don't always know in the population, but for Beyonce I do. She has a true mean that is right here. The mean word length is 3.53 for Beyonce. So when we look at our dot plot of the data that we collected, we notice that about half are below and about half are above. We were able to split right down the middle here. Okay, so we had a good statistic. A mean is a good statistic because there's something we call bias, or there's lack of it. It has no bias. So bias would be a systematic pulling in one direction. So if we had a similar dot plot So I'm going to make just kind of a quick little sketch of a dot plot that's similar to ours. Okay, they look the same, but what if my true mean was over here? Okay, so the mean is a good statistic for sampling, but this is showing some sort of bias where our data points were systematically pulled in one direction. Okay, so we don't want bias. So that could have been how we asked the question. It could have been our sampling technique. It could have been any number of things, but we had some sort of bias invoked here. So if you have a good statistic, the center of the sampling distribution should be around the true mean because we don't have a lot of bias. And the other thing that you want is you want a low variability. So when we're looking at our dot plot here, we range from 2.2 to 4.6. So maybe that's a bigger variability than we really want. So to have a lower variability, we took a sample of size 5. Maybe next time we take a larger sample size of 10. So take a larger sample size will give you a lower variability. All right, well, hopefully that was helpful to you. Let me know if you have any questions, and I'll see you in class.